a day to see could you go over my test 2 with me?
Yeah. Send me an email with some times that work for you. Or if you just want to stick around after class, we can work something out then.
Okay, then.
So whatever works for you there. Apart from that, any other questions before we begin today? All right, well, good afternoon, everyone. Hope you're having a great day today. So before we get started, I want to make a couple quick announcements. Inside of Canvas, I went ahead and averaged the 3 group assignment discussions. As long as you've submitted them all, you should be fine in that. If you didn't submit them, well, you know, that's you'll probably see that reflected in the grade. But apart from that, you know, everyone did really well on them. Certainly had a great discussion. It's kind of a bummer that the last discussion, I finally managed to pick one that got a pretty much 50-50 split down the middle, you know, kind of regarding whether or not Slack has a valid case. And, you know, beyond that, should antitrust regulations be, you know, a larger component of, you know, tech firms, or should they be a smaller component? So an interesting discussion. Certainly unfortunate that it didn't work out to have it, you know, in, I would say in person, but, you know, in terms of a live discussion, it'd be kind of an interesting one to have. Unfortunately, it just didn't work out. Apart from that, we're wrapping up this unit pretty soon. Tomorrow is the last day of, you know, lectures, so we'll cover the remaining 2 chapters from the book. We'll pick up, I think it's Thursday, with covering the Technology Guide 3, which I believe is cloud computing, and then also covering any sort of questions that you have about the exam, which will be cumulative. So you can ask any question about the 300 plus terms that could be on there. You'll certainly have the opportunity to do that Thursday. Any questions about today or anything? Any questions at all? All right, well, today we're covering Chapter 11, which is Customer Relationship Management.
So you said we won't meet tomorrow?
No, we will meet tomorrow. Tomorrow we'll finish up the, I think it's chapters, 8 and 6. We'll cover a lot of networking stuff tomorrow. And then on Thursday, we'll also meet. We'll cover the Technology Guide 3, which is cloud computing, as well as you can ask any questions you want about the exam.
Oh, okay.
So any sort of questions you have, I mean, you can also ask them today. That's perfectly fine. I'm just saying you'll basically have almost all class period on Thursday to ask any questions. So any other questions? All right, so yeah, again, we're covering customer relationship management today, as well as supply chain management. Now, I should probably preempt this by saying there's a lot of stuff inside of supply chain management. This is going to be a very kind of basic kind of overview of what it is. But certainly if this is something that interests you, you know, take some more supply chain classes. There's a lot of great opportunities in supply chain management, as well as things like industrial engineering as well. So if that's something that you're into, certainly, you know, you probably want to learn more about it beyond what's going to be taught in this class. But this class is going to cover the basics of it. And, you know, certainly we'll be inside of the supplemental Excel file to kind of do some really kind of simple yet pretty practical and pretty realistic examples of supply chain management. So without further ado, again, we'll be talking about, you know, different types of customer relationship management. We'll be covering supply chains as well, you know, how IT plays a role in it, and then actually doing some examples using supply chains. So I've got a quick little video here. Once again, I apologize, I can't play it, but it's a kind of humorous video where you have Dilbert speaking to his boss, and his boss is listing off all these different functional areas that he has to work with for a project that he's doing. And at the end of it, Dilbert says, "So what I hear is you want me to fail." And his boss says, "I'll meet with you again in a year." You know, that's it's kind of the whole joke there, is that, you know, the more functional units you work with, a lot of times it can seem as though it's more difficult. And that's probably true. You know, if you're working with 1,000 people versus working with just yourself, I mean, it's certainly going to be tougher to collaborate. And that's really where all this idea of customer relationship management kind of goes in. You know, we have the ERP, which allows us to, kind of collaborate across the organization. There's not going to be any sort of information silos that form. All the information is going to be distributed to the organization as needed. So it's going to be very beneficial to kind of reduce that problem that Dilbert faced. So let's talk a little bit more about customer relationship management. So as we know, the point of a business is to sell goods or services, sometimes goods and services. So with that in mind, we sell to customers. Ultimately, we have customers who purchase our products or services from us. And depending upon the type of business we are, we may want to have a good relationship with our customers. So, if we're a retail environment where we have a lot of B2C sales, maybe this isn't as important of a component. But imagine we're a more niche retailer where we're retailing to very specific people. We have maybe a lot smaller of a customer base. So, imagine a firm the size of Walmart. You don't really expect them to know, the name of your kid. You don't expect them to know the name of your dog. But if you're a smaller retailer, that sort of thing can go a long way. Making sure that you have a place where you kind of store that information can be pretty important. So that's really the whole purpose of a CRM, is to store information about our customers and to kind of help us better understand who they are. So, with that in mind, different customers are going to have different things. Like, for example, you could have some customers been with you for 30 years. They've been doing business with your firm, and that's a very kind of loyal customer. You could also have a customer who's brand new. Maybe they have a very high risk of churn and going to a competitor because they don't have that sort of long-standing relationship. So customer age is going to play a pretty big role in it, and just knowing how long the customer has been doing business with your firm. And then in addition to that, you want to know what kind of business they're doing with your firm. So are they doing just a tiny percentage of business with your firm? Or are they doing a very large percentage of your business comes from one or two customers? That's going to determine the customer value. Not to say that every customer is not valuable, but certainly if one customer is contributing, say, 30% of your firm's sales, that's a pretty important customer. Whereas if you had a customer who's contributing, let's say, 0.1%, that's not as substantial of a percentage. In other words, if you lost the 30% customer, that would probably lead to some problems with, lots of lost revenue. Whereas if you lose 0.1% of your sales, I'm not to say that that's not an important amount to lose, but certainly it's less important. So that's kind of what we're talking about when we're managing these relationships. And, ultimately, we'd kind of want to have a personal marketing approach where we're going through, and especially with our customers with high value, we're basically seeing, how can we better serve this customer? Are they sensitive to prices? Are they sensitive to, a smile? Whatever the case may be. Our ultimate goal is to better understand our customer and to be able to better sell them goods and services. So let's take a quick look at this little process here. So basically what this is saying that our target population is everybody. Everybody could walk into our store and buy a product or service from us. But within that, there's only some percentage of those people that are actually doing so. That's our customer base. So if you've walked into a store, you're right here inside the customers. But what we want to have happen is we want to have loyal repeat customers. So we don't just want to have people who occasionally buy from us. We want to have people who like our store. They like to come purchase from us, and they do so on a regular basis. In between this, you can actually have what's called customer churn, where a customer leaves your firm and they basically don't purchase from you again. So that's going to be very common inside of certain industries, particularly industries with either low switching cost or high amounts of competition. So if there's an industry that has very high switching cost, you're unlikely to churn, even if you're dissatisfied with the firm, simply because it'd be costly to do so. And the contrast is, if you're inside of an industry that has no competition, well, you can't churn no matter how upset you are because there's no one to churn and go to. Perfect example is, imagine a local utility company. Someone chime in here and tell me, what happens if you get upset at your local utility company? Do you leave them and go to another utility company? Or do you just kind of, I don't want to say bend over and take it, but I mean, that's pretty much what you would do. So
I would address it and then try to get like a discount for a certain time just because they haven't been doing a good job.
Yeah. So I mean, that's certainly an approach you could take. But the thing that I want to kind of illustrate is that, with a service like that where you don't have competition, you can't really churn. You can't go to a competitor because there is no competitor to go to. So those are the two cases in which customer churn wouldn't be something you'd look at. But then you want to kind of segment your customers a little bit further. And like we're talking about, you want to see these high value repeat customers that are going to be the ones you would heavily focus upon. And then the low value repeat customers as well. You wouldn't want to have a change that affects, every single low value repeat customer, because imagine you made a change and the customers themselves, the marginal utility that you gain from them may be quite minuscule. You may be looking at, sub 1%, sometimes even sub 0.001%. But imagine if those low value repeat customers make up 30 to 40% of your business and you make a change that upsets them and they reduce that to maybe 10, 20, maybe even 30%. That could be quite problematic. So you want to consider both groups, but you certainly want to more strongly consider your high value repeat customers. So that's pretty much what this process is saying. And the whole takeaway is that churn will happen, but it's less likely to happen in certain industries. So that kind of brings up an interesting discussion. If you're in an area that or if you're in an industry that has some sort of, problem where there's not a lot of competitors, should there be regulations? I'm not here to say whether there should or should not. Certainly proponents of regulations would say yes. Certainly people who are opposed to regulations would probably say no. So let's go talk about how you actually interact with a system. So anytime where you're interacting with a system, that's a touch point. The customer is basically having contact being made to them. A lot of times we see this in terms of, traditional customer contact, where maybe you get something in the mail, kind of has some information about upcoming sales, maybe new products or services that launched. Maybe there's even going to be phone calls. Phone calls are going to be pretty costly because unless you're doing some sort of robocalling, you're basically paying an employee to sit there and call people. I don't know about you all, but a lot of people don't answer their phones very frequently. I certainly don't answer my phone very often. I've got it set to not even ring if it's an unknown caller. So, unless it's someone in my contacts, I'm not going to take the call. I imagine a lot of people are in that place today. So that's not going to necessarily be the most effective way to reach customers. Instant messaging, though, can be quite effective because it means that the person is basically messaging you. The customer is interested, and they're going to use their instant messaging service to reach out to you directly. And that could be a kind of effective way. It's also going to be a lot lower cost because you can manage several IM conversations at a time. You're not limited to one single conversation as with a phone call. A website, of course, can be used to have lots of information about the products and services you provide. It can also be used to maybe do online sales. It could be used for things like support information. Lots of things could be used for a website. And that's something that the customers are going to directly interact with. And then there's, a multitude of other sorts of customer contacts we could use in terms of, having different marketing campaigns. This isn't a marketing class. You don't have to worry too much about that. But, like I say, if you have bad CRM, in other words, you're not properly managing your customers. Maybe you're getting their information wrong. You're sending their orders to the wrong place. This could even be things like, for billing. Imagine if you sent a bill to the wrong person. For one thing, that could certainly have some privacy implications, particularly depending on what the bill was for. I think you could probably imagine how that would go. But in addition to that, you could also just not receive the payment. If you get a bill for something you didn't order, you're not going to pay it. So that's certainly going to be another problem here. But as we talked about before, so we have customer churn, and that's only going to be in certain cases. But certainly in all cases, if you have bad customer relationship management, you're probably going to have some customer dissatisfaction. In addition to that, you could have reputational damage. If you upset a customer, that's probably going to go a pretty long way. People who are upset, they tend to talk about being upset. And when we think about, what that's going to impact, that's going to impact things like our goodwill. That's going to impact things like our brand. Those are going to be things that aren't going to be directly measurable, but certainly they do play a role into the value of our firm. So, we kind of talk about the intangible assets. That's what that's going to harm. So some of the things to consider there. But then as with any sort of system where we have a lot of information, we want to ensure that we have, no information we don't need. Everything in the system should be accurate and it should be correct. So we want to do data consolidation, as we've talked about in the data management chapter. This is where we're going to go through. We're going to make sure we don't have any redundant information. If we have redundant information, that could be pretty problematic. We're basically storing the same information multiple times. And imagine if we update it in one place and not the other places. And then down the road, we look at it in a different place it wasn't updated. We could very well lose funding. Or not funding necessarily, but we could certainly lose sales. So that's something that could be problematic. And then really the whole goal of CRM is to really just have a centralized place to kind of store information about our customers. And when we talk about this is going to be one component of the ERP system. So it's really going to help us transform our organization and remove sort of individualized information silos. And it's going to basically allow us to have all the information that we need at a really quick pace. I mean, we can easily obtain this information. We can do whatever we want to it, anything like that we need. So let's talk about some different.
Excuse me. Can you go back to the consequences of bad CRM for a sec?
Yeah, sure. Do you want me to repeat anything or just have it on here for a second?
No, you can go ahead. I just had to write one thing down. Thank you.
No problem. Yeah, so we talk about some different types of CRM. The first one we're going to talk about is the operational CRM. And this is going to be one where this is going to be probably the most common type of CRM. There's a lot of different types of CRMs. I'm going to go ahead and tell you some of them I don't think you'll ever actually hear called what the textbook calls it, but this is certainly going to be what we think when we think of a traditional CRM. This is where it's going to be focused pretty heavily on, sort of the front of office task where we have, the different departments that kind of interact directly with customers like sales, making the sale basically, marketing, reaching out, figuring out what our customers like, as well as service personnel. Post-sale, something goes wrong with whatever they purchased. They kind of want to be able to mitigate that. And there's two main components here. There's going to be customer-facing components, and there's going to be customer-touching components. So let's go ahead and in a couple slides, we'll talk about what those are. But for now, just know those are the two main components there. But this really provides a lot of organizational benefits in that we're able to, kind of better reach out to our customers. We've kind of talked about that. But in addition, we kind of hinted at this, but we have a very complete view of who our customers are. And, with that information, we can certainly tailor our future products or services to them. We can tailor prices to them. We can maybe tailor other things to our customers. And, again, we could kind of go back and we could talk about, we could certainly acquire existing data about our customers. We go to a data broker, maybe purchase information kind of regarding maybe past history of a person. We could we could maybe collect information about what else they purchased. And again, of course, there's going to be some ethical components to that. I'm not saying you should or shouldn't do that, but we can do that. That's what I'm kind of trying to emphasize here. So by having that more complete view of our customers, we can hopefully increase our sales and increase our revenue. So in addition to that, we don't have to just look for what they're purchasing in other firms. We of course have the information, what they're purchasing from our firm. And that's probably most important to us. Having what each customer purchases, when they purchase it, how often they purchase it, if they return it. That's pretty much the whole goal here. And again, as we increase our revenue, the main thing we want to probably do is to increase our profitability. So if we're increasing our revenue, but our profitability is staying the same or even decreasing, that's not beneficial to our firm because that means that we're not really gaining any additional profit. So imagine you had a case where you could sell more product, but in so doing, you would not gain any additional money. Would you do it? Does anyone think you shouldn't do that? So if you're a business, you're a for-profit business, the whole goal is to make a profit. So it doesn't really make sense to sell things at a loss most of the time. Not to say that you won't have cases where it will make sense to, but in most circumstances, it would not be logical to sell at a loss. So I kind of we're going to talk about customer facing and customer touching. The main distinction is where the customer interacts with the system. If the customer kind of interacts through some sort of intermediary, that's going to be a customer-facing application. So in other words, the customer is not directly inputting any information. They're not directly receiving any information. Instead, they're going through some sort of employee, maybe some sort of, some sort of mailing, something like that, to where they're not directly interacting with the system. A lot of times we hear a term called Customer Interaction Center. That's basically a call center where you can call a hotline of some sort, get information about the products and services they provide. The reason it's called a customer interaction center, a lot of times they do additional things like they do web chat support, maybe they do email, all that sort of thing. But the whole thing, you can think about it as a customer interaction, it's basically a call center. And with this, we're able to kind of automate a lot of tasks that previously we weren't able to automate. For example, things like sales history. You don't have to manually input what a customer purchased because it's automatically done when they purchase it. Things like storing your customer's information. Again, it's going to be automatically done. You don't have to have a Rolodex on your desk that you kind of flip through to do that. It's just going to be stored whenever a customer purchases. And then any sort of additional sales leads. Lots of things are going to go into this, but basically the whole concept is that stuff you used to have to do manually as a sales personnel is now done automatically. And then customer facing, again, there's an intermediary involved. In customer touching, there is no intermediary involved. The customer is basically going on to a website. A lot of times it's a website. It's not exclusively a website, but most of the time they're going to go into a website and basically interact with the system themselves. So this is commonly referred to as an eCRM. When I say commonly, I mean commonly in an academic sense. I don't think I've ever heard that as a practitioner, an eCRM system. But the whole concept is that people are able to find help basically 24/7. They're not limited to whenever your sales staff is working. They can go purchase products online. Sometimes they can use other means of communication. And basically 24/7, they can directly seek help from the system. Common example of this, of course, can be an online web store like we've talked about. But that's not the only example you could see. You could also see examples like maybe even a kiosk or a self-checkout. Those sorts of things could certainly be customer touching applications because the customer themselves is the one who is directly interacting with the system. So, if you're going to have this information online, it's important that people be able to easily find the information that's within it. So, for example, if you have maybe some frequently asked questions, you'd probably want to make sure that you could easily search through those frequently asked questions to find what you're looking for. So, if you have information about how do you reset your account and password, you'd probably want to make sure that you're using, those tags. You're using things like reset, using a tag like password, maybe other tags that kind of go along with that, maybe passcode if people, don't use password as the kind of language there. So that's going to go a long way in terms of making the information accessible. It's pretty self-explanatory there. But in addition to that, if you have an eCRM, it can be very beneficial that you tailor the recommendations. You tailor the product recommendations. Maybe you tailor the appearance of the page to suit the individual customer. So a great example of this, if you sign into your Amazon account, you probably have products or services that interest you because you've searched for them before, maybe you've bought them before, whatever the case may be. And in addition to that, you could also see products or services that may complement what products you already own. So if you purchase maybe a gaming console from Amazon, they might suggest to you games that use that console. That's certainly a pretty common example there. In addition to that, making sure that you have ways to interact with customers on an eCRM platform, that's going to be very beneficial. These don't have to be real employees. They could be, some sort of chatbot software where basically you have a pretty good idea of what the customer is asking for. And a lot of times it's going to be programmed to where if it goes back and forth 3 times, then it will say, okay, let me get a real representative. But in most cases, that's going to be able to address any sort of customer problems within, 3 responses. And then lastly, you can certainly have a loyalty program. These are not necessarily a mandatory thing, but a lot of firms do loyalty programs to kind of incentivize repeat business. And certainly repeat business is going to be more profitable long term than one-off business. So that's kind of some considerations. And these are considerations that extend well beyond just the traditional ERM system, or CRM system rather. But there's a lot of other types of CRM systems. The on-demand CRM system, basically, it's not entirely, but it's basically where you have it hosted by a third party, software as a service. Mobile CRM system is a CRM system that emphasizes you use of mobile devices to access and update information. Open source CRM is basically just a CRM that you have the source code to, And then lastly, a social CRM, as the name implies, is one that emphasizes social media integration. Now, I'm going to go ahead and tell you, pretty much none of these are going to be used, none of these terms, rather, are going to be used in industry. CRM is basically a CRM in industry. So you don't have to worry about knowing those different terms right there. Any questions about CRM so far? Again, I'm always happy to answer any questions. But let's talk about supply chains. Supply chains are really a great chapter. And when we talk about what a supply chain is, it's basically just how goods move across the supply chain. This is a highly misunderstood chapter, though. It's not uncommon to see people who refer to themselves as supply chain manager. And then you speak to them and you say, oh, well, what do you do? And then they might manage one part of a supply chain, but not the entire supply chain. It's very difficult to manage the entirety of a supply chain. There's really only two cases in which that could actually happen. The first case will be a command economy, in which the supply chain were centrally managed, where basically the government would basically, control each and every aspect. In that case, there could be a supply chain manager. The other case could be in digital distribution. With digital distribution of goods or services, it is possible to control the entirety of the means of production, particularly if you're a company like Apple or Microsoft, where you have an app store and you have apps that you put on the app store. That's pretty much the only two cases you're going to see a true supply chain manager. A lot of times what people refer to as a supply chain manager would actually mean an operations manager, or some sort of a lesser, I don't want to say lesser, but some sort of a position that has kind of fewer components of the supply chain encompassed within it. So, within this, though, we have the supply chain. It's basically the flow of goods and services from the suppliers all the way to the end consumers. And there's lots of different parts to that. We'll talk about those in the next couple slides. One of the main problems that we see with supply chains is that information may not be passed throughout that supply chain very well. So there could be some information asymmetry. In other words, maybe the supplier has information that the manufacturers don't get. Maybe the manufacturer has information that the distributors don't get. This kind of goes pretty far back. And that's really the issue of visibility. What information is visible across the supply chain? So organizations like Walmart, they actually force a lot of their suppliers to use their ERP and to actually put in what sort of quantities they have, where are the quantities, all that sort of thing with their inventory, so they can have better visibility across the supply chain. I'm not saying that's a good or bad practice, but from Walmart's perspective, it's certainly very beneficial. And then in addition to that, you also want to consider the inventory velocity. For supply chain, this is a very important topic because this is saying how fast are the goods and services moving across the supply chain. If we have a very slow moving supply chain, maybe there's some things we could do to improve that speed and to make it less of an issue. Because if we have a lot of cash tied up inside of our inventory, what does that do for taxes? Someone chime in here and tell us what that does for taxes.
Do they go up?
Yeah, of course, they certainly do go up, and that's a great point. So, you're taxed on your inventory. You want to minimize your inventory. Not to say that's the only thing you're taxed on, certainly, but, that's a very big consideration. And if we have a very fast-moving supply chain, we can minimize that. If we're using things like just-in-time, we can minimize the inventory we keep on hand. There's also going to be a very important consideration for supply chains where there's going to be some sort of spoilage possible. A lot of times products don't last forever. Maybe technology sector, maybe within 6 months there'll be a new version coming out. The old version is going to be pretty hard to sell at a full price, of course. Why would you buy the old version when you can buy the new version for the same price? Then in addition, we think about things like food. Would you buy a rotten banana? I don't think many people would buy a rotten banana. There's a very short window of time that we can, purchase a banana. You don't want to purchase one that's completely green most of the time. And you also don't want to purchase one that's completely, brown and bruised. I mean, you'd want to have it to be that perfect shade of yellow. So that's what we're talking about when we're talking about inventory velocity, is ensuring that the supply chain is moving at a good pace. So here's just generic supply chain. This is a very important chart right here. Most of the charts I kind of tell you, you don't have to necessarily remember the whole thing. This is one that's not too difficult to remember, though. So right here at the center, we have the manufacturer. And that's basically the person who's making the product or service. In this case, let's just use a cell phone, for example. So let's say the manufacturer in this case is Samsung, and they're making cell phones. And, they have, on this end, they have suppliers. They're purchasing products from suppliers to make their cell phones from. So let's just say that the tier 1 supplier here could be something like a system on a chip manufacturer, where they're basically purchasing boards that are ready to stick inside of a cell phone, for this example. Well, then the tier 1 supplier has a tier 2 supplier. In other words, they're purchasing something from a tier 2 supplier. So if they have completed boards that are their product, then the components that go on the board and the board itself is going to be what they're going to purchase from the tier 2 suppliers. So in other words, you have maybe things like processors that they would purchase from tier 2 suppliers, maybe transistors, maybe capacitors, maybe things like the PCB board, possibly also things like solder. That's going to be purchased from the tier 2 supplier. And then the tier 2 suppliers are going to purchase things that are going to be even more raw. So they're going to purchase things like maybe silicon. Maybe they would purchase lead for lead-based solder. Maybe they'd purchase whatever else goes in solder. I mean, those are certainly components that they would purchase. So basically, what we see as we move throughout a supply chain is that as we get closer and closer to the manufacturer, we get closer and closer to the actual goods. So a tier 1 supplier is going to have a more finished product than a tier 2 supplier. And a tier 2 supplier will have a more finished product than a tier 3 supplier. If we use the example of a manufacturer of automobiles, let's say Toyota, for example, they're manufacturing a car, but they're not manufacturing each individual part of the car. A lot of times they're purchasing those parts. So maybe they're tier 1 supplier. Maybe they're buying things like airbags, maybe they're buying things like seats. Maybe they're buying things like steel for the frame. Maybe they're buying things like, sort of like a dash unit, something, like some sort of entertainment unit. We look at a tier 2 supplier for those things. Maybe they would buy things like cloth for the airbags. Maybe they buy things like whatever chemicals they put in the airbag. I'm not really sure. Certainly those sorts of things. If we stick to the airbag example, we go back to tier 3. Cloth's probably made out of some sort of material, maybe nylon, maybe it's made out of cotton. So that would be the sort of things we'd have inside of tier 3 suppliers. It's basically just breaking down the product more and more. But then if we go towards the manufacturer, what they're doing is they're basically assembling all of the different products into one complete product. So, most of the time, assuming no one in here has ever gone and bought an airbag, if you have bought an airbag, you probably had your old one deployed or something. And, that's certainly, but it's unlikely that a person would go directly to a tier 1 or tier 2 supplier. You're probably going to manufacturer, you're buying a car. I imagine a lot more people have probably bought a car in this room. Well, I guess I'm the only one in the room, but you get what I'm saying. Inside of this meeting, it's more likely that people bought cars than they've bought airbags. And, then we kind of go through and we want to, instead of selling directly to the customer, which we could do through disintermediation, as we talked about, we could instead go through a distribution sort of chain where we have, various distributors. Maybe we have different wholesalers, and then they sell to retailers. And then ultimately, the customer purchases the product from the retailer. And, ultimately then the consumer would use the product. So this one doesn't actually include consumer, but consumer would be kind of on the right of customer, where the ultimate consumer is the person who actually uses the product. Sometimes it could be the same as the customer, but it doesn't have to be the same as the customer. You think about a lot of people using devices today. A lot of people purchase their own devices. Some people don't. Some people, maybe they have a parent who purchases them. Maybe they have a spouse, whatever the case may be. Certainly, it's important to kind of understand the distinction between a customer and a consumer. So again, if we're a business, we're probably more focused on the customers because those are the people who are actually purchasing the product or not. They're making those decisions. So yeah, this is basically how a supply chain works. You have the different kind of aspects of it. If we wanted to remove one of these aspects, it's called disintermediation, as we've talked about. But then there's going to be information going both ways. So we have information flowing down from the customer all the way to the tier 3 suppliers. And then information also flows up. In addition to what's flowing kind of up the supply chain here, we have things like the product itself. It's going to go from the tier 3 supplier all the way up to the customer. Of course, it's going to be a lot more assembled than when the tier 3 supplier had it, but that's kind of the whole point here. So we think about the payment. The payment's going to go, basically up the supply chain there. So any questions about this kind of generic supply chain chart?
Can a manufacturer have more than just 3 tiers?
Yeah, certainly. I mean, this is not exclusive to 3 tiers. And sometimes there may be fewer than 3 tiers. It just kind of depends on what the product or service is. So, imagine if someone were selling sand. I've certainly gone out and bought sand a couple times in my life. That's probably just one tier 1 supplier. They go dig up sand from somewhere and then they bag it up and sell it. But there can be some examples where there could be a lot more than 3 tiers. That's a great question. Any other questions?
You might have mentioned this, but how are they based? Is it like off of importance for tier 1, 2, and 3, or?
So basically, the thing is that a tier 1 supplier is going to have a nearly completed product. And basically what the manufacturer does is the manufacturer would purchase those from tier 1 suppliers, where it's basically nearly completed. Like they're purchasing maybe an airbag, they're purchasing like a windshield, maybe like a car window, that sort of thing would be tier 1 supplier. As we move kind of down though, we would see that in tier 2 supplier, they'd be purchasing things like glass for the windows. They'd basically be making the window. And, that's kind of what we're talking about there. So, it's as we move further away from the manufacturer, it's going to become less and less of a completed product. So as we move closer to tier 1, it's going to become more complete. Does that make sense?
Yeah, thank you.
All right, any other questions? This is a very important chart right here. You don't have to memorize it for the test, of course, but certainly to understand, the different components of it are very important to do. So when we talk about supply chain management, really the whole purpose behind this is to kind of, minimize the cost of doing business, the cost of goods sold. And we do this through the same processes we've used throughout the semester. Early in the semester, we talked about the DMAIC process. Well, this is quite similar. First we want to plan. We want to see what good or service do we want to sell? What sort of prices do we want to get? Then we actually acquire the materials we need. After we do that, we sort of assemble it. Then once we've assembled it, we go ahead and deliver it to the customer. Now, this, of course, is going to be encompassing many different elements here. If we look back at this chart here, this is basically encompassing the distributor and the retailer. And then lastly, we handle any sort of returns that need to take place. So that's basically the entirety of the supply chain management. It's in these 5 little steps here. So we start off at the manufacturer. We plan what we're going to make. We determine where we're going to acquire the stuff. We go ahead and source the material as a supplier. We interact with our tier 1 suppliers here. As a manufacturer, we make the product, of course, and we deliver it, and then we handle any sort of customer returns. So pretty self-explanatory there. But with that in mind, it's important to kind of remember that this is involving multiple organizations. Even with full-scale vertical integration, we're going to integrate as much of the supply chain as we can. It's still going to involve multiple organizations. So with that in mind, a lot of times we'd use something called an inter-organizational information system. And basically, this is just a system. It's basically an ERP system that we share with the different elements of the supply chain. So Walmart does this, and I'm sure other retailers do as well. Walmart just happens to be the most famous example of this. It's going to provide us a lot of benefits, though. So because everyone is using the same data, we have very high visibility among the supply chain. We have a pretty good idea of where our inventory is, where our supplier's inventory is, and so forth. And that's going to have some pretty substantial benefits for us, particularly things like reducing the cost of a transaction. There's a huge amount of research on transaction cost economics. And what that's basically saying is, what is the kind of costs that don't really contribute to the product itself? In other words, it's saying like, what are the fixed costs of a transaction? So by having all the information in one place, we can reduce that throughout the chain. It's also going to make sure that we have higher quality information, hopefully more accurate information. We have a better visibility over what our suppliers have and what our other partners have. But then ultimately, it's going to make our supply chain have a greater velocity. It's going to have, less sort of hold up along the way because we can more appropriately, or we can better kind of adapt to any sort of changes that may arise. And then this is probably the most important thing we can do. This is going to eliminate a lot of paper records. So if we didn't have a system like this in place, we may have mountains and mountains of paper records. But using inter-organizational information systems like this, we can greatly reduce that amount of paper that we have. We don't have to have things like paper invoices between suppliers. We don't have to have things like paper inventory slips. This can all be done inside an information system. And that's going to greatly kind of reduce the time it takes to process information and also allow us to process information we otherwise would not be able to. So that's really kind of the whole purpose of why we would do that. So again, we talked about vertical integration. Just talk about it a little bit more here. Vertical integration, of course, is wherever we would take different elements of the supply chain and we would incorporate them into one company. So looking back on here, the generic supply chain, it would be vertical integration if we bought a tier 1 supplier. And then if we bought a tier 2 supplier, that'd be even more vertical integration. Because then we're kind of buying more and more of what we need to produce our products or services. A great example of this could be, let's say we're a manufacturer and we manufacture spaghetti sauce. So what goes into spaghetti sauce? Of course, we have tomatoes. So we buy up the tomato farms. I'm sure there's some spices that go into spaghetti sauce. So maybe we buy up oregano farms. I don't know if you have an oregano farm, if that's even a thing. But imagine it were, and we bought it up. Then in addition to that, the things that go into tomatoes production, we bought up a fertilizer company. That's even more vertical integration. We take it a step further. We buy up a topsoil firm. We buy up a water firm. All those sort of suppliers we buy up. That's going to increase the level of vertical integration across our supply chain. So that's one way we can kind of mitigate any sort of issues that we may have. Now, I'm not to say that's going to be the silver bullet where you could just buy up your suppliers and fix any sort of problems, but it's going to allow you to have a more customized product, and it's going to make you less sensitive to market fluctuations. In addition to that, we just-in-time inventory, where basically we're reducing the production, we're reducing excess production rather, and we have a production system in place where we have a smaller reliance on having expensive fixed costs, and instead we have more variable costs to where we can easily scale up and down production as needed. We're also going to reduce the sort of inventory on hand and all that sort of stuff with just-in-time inventory. Information sharing, we kind of talked about, making sure that different aspects of the supply chain here, making sure they share the common information. There's a high level of visibility there. Then lastly, vendor managed inventory. That's pretty common for certain things, particularly things like bread, where most grocery stores, they purchase bread on consignment. They're not actually buying the bread. They're basically renting the shelf space out to a bread company, where the bread company kind of goes and they stock things. I think chips do the same thing, and sometimes soft drinks as well. Where basically the vendor is responsible for managing the inventory, and they kind of determine what the demand will be based on several things, and probably also based on sales data from the firm, which they get through information sharing. So, as you may guess, IT plays a pretty big role in kind of enabling that sharing of information. If you had to, have the transactions on paper and you had to send off, just mountains of paper every single day, how's anyone actually going to go through that? Well, they're probably not. So instead, we'd use things like an electronic data interchange, where we kind of enable the easily transfer of large amounts of information. And it doesn't even have to be manually done. This could be automatically done. Where we get a sale, it's automatically entered into the system that we just happen to share between our different suppliers and our different, maybe other people along the supply chain. Certainly one way we could kind of do this. Another component is going to be the extranet. We're going to talk more about this next class, but basically this is going to be a specialized network where we're basically enabling the sharing of information across maybe an industry. It's pretty common for industry extranets to happen. It could also be across our supply chain. Basically, it's just two or more organizations sharing some element of a network with each other. And then lastly, we have the whole concept of having portals and exchanges. Basically what these are just basically websites where you can go to and we can easily see information that's tailored to a specific interest. In this case, we'd be talking about a specific supply chain. And basically just kind of be able to easily change information. All right, so we're not quite done for the day yet. Just kind of wrap up what we've talked about so far. We talked about CRM. We talked about different types of CRM, specifically focusing on the operational CRM because that's the most commonly used and certainly what we think of when we think of a CRM system. And then we also talked about supply chains, the different elements of a supply chain, some different techniques to kind of better manage supply chains and how IT plays a role. Any questions so far? All right, certainly feel free to ask questions at any time, but I'm going to go ahead and share my screen here. All right, so like I said, we're going to be inside of the Excel file today. This is the SCM supplement. It should be inside of Canvas. Let me know if it's not, but it should be there. And basically, there's three main kind of worksheets here. We have site selection, we have bottlenecks, and we have make or buy decisions. So, these are going to be kind of cool little examples here where we're going to kind of apply some more stuff inside of Excel. And this is stuff that, pretty common business decisions to make. Purchasing a new site, that's very common to decide to do. Solving any sort of bottlenecks with a business process, that's pretty common to do as well. And then also, determining whether you want to make or buy a good, that's certainly pretty common. So let's just go ahead and start off here. So as you can see inside of this first site selection spreadsheet, we have different cities. Some of them real, some of them not so real, but that's okay. We have different states, we have different populations within each of these areas. We also have different demand for the area, as well as per person demand. Then we have a different happiness. So happiness is going to be out of 10 as we see here. So 10 being the most happy, I guess 0 being the least happy. But luckily we don't have any city that has a 0 happiness. We have city pollution out of 100. This is going to be coded a little bit differently, where you have 1 being no pollution, and you have 100 being, I can't believe there's even air. It's pretty much just pollution, I guess. And again, I did make up a lot of these numbers, so certainly no offense to any of these cities on here. And then we want to be able to scale these. So the whole purpose of having a scale is to be able to directly compare cities, basically using kind of a fair technique, a fair metric rather. We have the different latitude and longitude, and ultimately we have different weighted latitude and weighted longitudes. So in order to kind of have a fair scale, it's important that we first kind of determine what are the max and minimum of each of these categories. So what I have here is I have the sum, which is going to be where we take the entirety of the observations for these 7 cities. Then we're going to take the max value of the 7 cities. And lastly, we're going to take if there's a difference between the max value and the max observation. So that'd be like for city pollution, for example. The max value of pollution is 100, but we don't have any cities with 100 pollution. So let's go ahead and get started on this. So to start off, we're just going to do the sum, because that's all we're doing inside of here is we're just taking the sum, just going to grab this whole range here, and that's all we have to do. Now the cool thing about this is we don't have to manually type sum for all these. We can of course copy this formula over. So if you just select inside the cell, you should see a rectangle at the bottom right that's a little bit larger than the rest of the rectangles. When you mouse over that, you should see a plus sign. You just click inside that plus sign and drag over. And that's going to go ahead and take the sum of all those things for us there. Pretty cool little Excel trick. Maybe a review to some of you. Maybe some people just learned something new. So next, let's go ahead and do the same thing with max. We want to take the max value. And again, we're just going to do the same thing. We're just going to select the different cities here. Hit enter. We see the max value, of course, is 12 million. So we're going to copy that over. And that, of course, is going to do the same thing. Now for max value, I am, let's go ahead and do max again. And we'll just change it for the ones we need to. Which I think it's only 1 anyway, so it's not a big deal. Okay, so city happiness is correct, but this one needs to be out of 100. Yeah, that looks good to me. So did I lose anyone so far? Is this pretty straightforward so far? I certainly hope I didn't lose anyone so far. But next what we want to do is we want to create a constant kind of scale. And so the first thing we want to do here is we want to kind of determine what is going to be kind of how we do this. So ideally, we would have this scale be out of, I believe we have 6 different categories here. So it's going to be out of 6. So basically what we could do is we could simply take we could just take the population and we could just divide it by the max population. And if this is in fact the max population, then that's going to be 1. If it's less than that, it's going to be less than 1. So since we're going to copy this down, I do want the population to change for each city as I copy it down. But if I don't do an absolute reference on the max value here, it's not going to work because it's going to copy down and it's going to go C12 for this row, but then the next row is going to be out of C13. Thereafter that's going to be out of C14. So to alleviate that, I'm just going to make this an absolute reference where I just press F4. And now as you can see, we have the $ in front of the row and column, meaning that as I copy this down, only this first value, C2, will change. So the next row will be out of C3, then after that will be out of C4, C5, and so forth. So as you can tell, it's a pretty small number. But as I said, we're at a pretty good place for New York. You know, it's out of 1. So we take 12 million out of 12 million, that gives us 1. But that's only one of the different, it's only one of the different components. We want to have 6 different factors here. So we're just going to do a similar thing for each of these. We're basically going to take the kind of what they have as the observation and divide it by the max for that variable rather. So because we have order of operations, we don't have to put these in parentheses, but it's probably best practice too. So I'm gonna go ahead and do that because of course, you know, division is going to come before addition when it comes to any sort of you know, arithmetic operation. So let's just go ahead and do the estimated demand next. So type that out, get the cell D2 right here, divide it by the max of demand, make that an absolute reference. Let's go ahead and do the same thing here on per person demand. So we just want to get the max value for each of these. It's a little bit tedious to do, but I think it'll be worth it in the end. And now right here, because the actual maximum amount of pollution is different than the max of our observations, I made sure to select the max value for the final max pollution. So we're just going to go ahead and add these up here, and we get our different values. So basically what this is saying is that we're equally weighting each of these 6 categories to where we're basically taking the proportion that we have, kind of divided by the total amount that we could see. But I tell you what, though, I'll give someone 10 points on exam 3 if they can tell me what the mistake I made in this is. There's a pretty big mistake I made. Give someone 10 points so they can tell me what it is.
Is it you copied the max and the max value on
No,
the
so that's,
H through J?
No, so that's actually you talking about that I used the max value for the pollution index?
On max and max value, H through J, they're the same. I didn't know.
H through J. No, that's pretty typical because what we're seeing here is that it's just taking the max and the min, or the max. So it will be the same except in the case of pollution because pollution's out of 100 and the max is not 80, it's 100.
I got you.
That's the only reason that's going to be different. Same thing with city happiness. If I didn't have Millerton as a 10 out of 10, then this would be different. But because it is a 10 anyway, it's not going to be different. Good guess, though. Any other guesses as to what I did wrong here? I'll give you a hint. It has to do with the pollution calculation. Anyone want to take a guess as to what I did wrong when I calculated the pollution?
And it's not because you used the 100 instead of the 80?
No, that's going to be correct in this case, but you're close. Anyone want to take a guess? So pollution is, in fact, out of 100. Any other guesses? Okay. So basically, the issue with how I calculated pollution is, as I said earlier in this, the kind of explaining these, pollution's out of 100 such that if you have 100 pollution, you're going to have basically pure smog. I mean, there's not going to be a molecule of oxygen in that air, basically. That's probably an exaggeration, but you kind of get the point there, is that 100 pollution would be very bad. But as is, the higher the pollution is, the higher the score will be, meaning that pollution in this calculation is beneficial. So in Millerton, for example, 1 out of 100 is going to give us 0.01 that is going to add marginally to our scaled value. But in some place like New York City, it's going to give us 0.8 marginal. We want to actually inverse that to where we favor cities with lower pollution. So to do that, we could simply take our value here and we're just going to subtract off 100. So first, let's go ahead and make sure we're doing the order of operations. We're going to subtract off 100 before we do anything else. And if we have 1 minus 100, that's going to give us a negative value. That's not what we want. So next, what we want to do is we want to go ahead and multiply by -1. And then we want to divide by 100, which we're already doing with this G13. So this should give us a higher value on Millerton. And it does. So as we copy this down, some of these values should change depending on whether or not their pollution was larger or smaller than 50, which is the median. So that's an important consideration to make, is that we're basically having the correct sign on our different variables there. Kind of a tricky question, but certainly it's one that's important to kind of focus on. Does everyone understand that, though? Did I lose anyone on anything so far? All right, so next we want to kind of consider how we would calculate a weighted latitude and a weighted longitude. So the whole purpose behind doing a weighted calculation like this is to determine what the effect is, or what each kind of value should kind of sway things. So for example, if I just average all the latitude and longitudes, that's going to give us somewhere kind of in the center of each of these different points on the map. Now, again, I completely made up these numbers, so who knows where that would be. But we instead want to see, based on whatever kind of scale we assign, where things should go. So, for example, if we look at the estimated demand, we have a pretty good idea about the relative proportion of total demand for each of these different points. So let's just kind of go over here and let's kind of see what we can do here. So if we start off by kind of looking at these, we can just basically take the kind of weighted demand, or the estimated demand rather, divide that by the max demand, which is right here, and then we can just kind of multiply it into the latitudes. Let's go ahead and do that. So again, I'm just going to go ahead and take this estimated demand divided by the total demand. In this case, we're not going to use the max demand. We're going to use the sum of the demands. Because if we use the max demand, we'd basically be greatly kind of overstepping our bound. We'd be multiplying by a factor greater than 1. And we can't really do that. So next, we're just going to take this. We're going to multiply it by the latitude. Okay. And we're going to go ahead and copy this down. So Now we just want to take the sum of all these. And that's our weighted latitude. Let's do the same thing with longitude here. So we're going to take, again, the estimated demand. Let's put this inside of parentheses so we make sure we're doing the order of operations properly. In this case, instead of multiplying by the latitude, we're just going to multiply by the longitude. And again, we copy this down, take the sum, and you get the answer there. So does that make sense to everyone? That's one way to calculate weighted latitude, weighted longitude. It's not the only way. I mean, there's certainly a multitude of different ways, but that way's pretty straightforward. So we're just taking the estimated demand, dividing by the total demand that we were accounting for, and then multiplying that proportion by the latitude to determine what the relative effect is. So for example, a city with a huge amount of demand, which is San Francisco in this case, is going to have a lot greater impact on the latitude and longitude. As you can see, 0.005 versus 17. Same thing with New York City here. We're comparing, 0.06 to 21. So that's basically all we have to do there. Pretty straightforward. Any questions, though? I'm certainly happy to address any questions. All right, let's go ahead and take a look at this second worksheet here where we have bottlenecks. So bottlenecks are a very kind of important thing to look at. And basically the whole premise here is that there's a couple key components within this bottlenecks chart. So the first thing we want to do is figure out how long it takes to complete. That is to say, if we have a single unit that we want to run through the supply, whatever this process is, how long is it going to take to complete? So to do that, all we have to do is just take a sum of all these times. We're going to take a sum of all the times for each of these individual sub-processes, or in this case, they're listed as tasks. So we take a sum. That's saying that if we run one single thing through this process from start to finish, it's going to take 41 minutes, or whatever the unit is. We're going to use minutes because that's pretty straightforward. In addition to that, though, we want to take this a little bit further. We want to see what is the weighted time. And weighted time is an important thing because it gives us an idea about how we actually would kind of determine how long each of these things takes given the different constraints. So to do that, we simply take our time divided by the amount of paths that are going through it. So I don't really have a great way to do this, but I'm just going to kind of show you what I'm talking about when I say the paths going through it. So basically we have task 1, and we have task 1, and we have task 1. And there's 3 of them. We see 3 paths. Those are going to feed into task 2. So imagine there's an arrow going from here to here. There's an arrow going from here to here, and an arrow going from here to here. That's going to feed into task 3, which we have 1 path. And then finally, that's going to feed into task 4, which we have 4 paths at the time being. Okay, that's basically what this looks like. It's not the best way to illustrate it, but given the fact I don't have a whiteboard to really write on right now, it's kind of the best way I can kind of show. So this is kind of a linear thing where you go from task 1 to task 2 to task 3 to task 4, with the caveat being that you have different amounts of kind of paths within some of these tasks. So we calculate the weighted time. We simply take the paths and divide it into the total time. So if we have 3 paths and we have 15 minutes per path, we basically have a weighted time of 5 minutes because it basically, the end effect being that it's going to take 5 minutes to kind of go through that path. So now we can kind of see which one of these is going to be the bottleneck. So we're going to use our good friend the if. We're going to say if this value right here is going to be the largest. So if it's the largest, we could do a value of true. If not, we could do a value of false. So that's one way we could certainly kind of do that. But there's really a lot of different ways to do that. So we're just going to say if it's the max value. We're going to keep it nice and simple, though. We're just going to go ahead and say this is the bottleneck. So That's pretty much what we would do to kind of determine what the bottleneck is. Then we look at capacity. And capacity, all we have to do is just add up the waited times. So we take these different waited times here, we add them, and that gives us, in other words, we could send basically 27, takes us 27 minutes to get a single product through. Not to say that that's to be confused with the time for completion, because time for completion is not factoring in the waited times. It's saying from start to finish. Whereas this is saying that basically every 27.25 minutes, we can get a product out. So does everyone understand that distinction? Is anyone lost? Okay. So let's go ahead and take a look at this. Let's go ahead and add up 3, 4, 5, and so we have 9 total paths that we can work with here. And let's go ahead and kind of rearrange these. This is going to be a recommendation. We want to minimize the amount of waited time we have. So currently we have 27 minutes. We want to see if there's anything we can do to reduce this capacity here and kind of reduce the overall waited time. So let's go ahead and do that. So right off the bat, we have 9 total employees to kind of allocate, or 9 different paths, whatever you want to call it. So, we want to minimize the waited time. What has the most waited time at this exact moment? Someone chime in and tell me that. Which one of these different paths has the most waited time? So in other words, I'm asking, is task 1 at 5 minutes, is that the longest? Is task 2 at 1 minute the longest? Is task 3 at 20 minutes the longest? Or is task 4 at 1.25 minutes the longest?
It seems that task
3.
Task 3.
I absolutely agree with everyone who just chimed in. It is, of course, task 3. So what we're going to do is we're going to say, well, task 4 only takes 5 minutes and we have 4 people on it. Let's go ahead and make this 1 person. And now we have 3 additional employees to assign here. So let's go ahead and do this right here. And now we've kind of reduced our bottleneck probably to about as much as we can. Where basically we now have a capacity where we're going every 16 minutes, we're able to get a new item out, whereas before it was 27.25. So to kind of calculate the time we're going to be able to do per hour, we can certainly pretty easily calculate that. We're just going to take 60 for 60 minutes in an hour and divide it by the overall kind of weighted time, the sum of the weighted times. I forgot to put an equal sign there. That's my bad. In other words, every 3 points, we can get out 3.75 in an hour. Does that make sense to everyone? So for a recommendation, we just say something like remove employees from task 4 and assign to task 3. That's a pretty simple recommendation. Now we have this this next kind of process. Now we have 5 tasks this time. So let's go ahead and add up the time for completion. So we take the total time here, and I forgot to put the sum. It's easy to forget to do things, but it's important to make sure you correct it before you're done, at least. So now we kind of have a different outlook here. So let's go ahead and add up these paths. We have 5, so we have 11. And the reason I'm not using the sum command is that as I change these, I want that number to stay constant. So that's why I'm just adding them manually. So we're going to go ahead and calculate the weighted time. So again, as we did before, we just basically copy this where we take the time divided into the amount of paths we have. I'm just going to copy it, keep it nice and simple. And right off the bat here, which one of these tasks is currently the bottleneck? Someone chime in and tell me which one of these tasks is the bottleneck. Is it task 1, task 2, task 3, or task 4, or task 5? So just to kind of remind everyone, the bottleneck is the process that has the largest waited time. So
Task 2.
That would be task 4.
yeah, so task 4 is correct. Task 2 does have the longest time, but we're looking at the waited time specifically to determine the bottleneck. So task 4 currently has the largest waited time. And the reason for that is because we're basically seeing where the holdup will be. If we're having different processes go, we're having something go through task 1. Let's say task 1 takes 15 minutes to go through, but we can have 3 things going through it at once. So if we add a 4th one on here, it's going to reduce that even further. And if we add a 5th one, we're really going to be cooking with gas, and we're going to be able to get through this in 3 minutes, basically. That's the effective time. Now, that said, of course, each individual thing will still take the full 15 minutes, but it's just we're able to kind of realize those savings. So it's a little confusing. It'd be easier if I had a whiteboard to explain things on, but unfortunately, I don't at the moment. So we're going to make do with what we have, and certainly. So let's go ahead and calculate at this exact moment what our capacity is. It's going to add up these weighted times here. I keep on forgetting the sum, don't I? To actually tell Excel what you want it to do. So then if we're going to take 60 divided by the sum of the weighted times, means that we can get about 2.9 products out per hour. But that's not the best we can do. You know, looking at some of these weighted times, they're pretty different. So a little kind of shortcut is that you want to have the weighted times be as similar to each other as possible. Now, for this class, we're going to assume that you cannot actually, assign half a person or half of a whatever the unit are. You can only assign a full unit. Just keep things nice and simple. So right off the bat here, we see a 0.666 repeating. So this has 3 employees assigned to it. Let's go ahead and take 2 of those employees off. So we're just going to make this 1 employee. And let's go ahead and assign them to the bottleneck. So now we have 3 here. And what does that do to our bottleneck? Is task 4 still the bottleneck, or did it change? What do you guys think?
The new bottleneck is task 3.
That's exactly correct, because now we see that the lowest weighted time, or the highest weighted time rather, is now on task 3. So now it's the bottleneck. Let's go ahead and take a further look at this. We also have a weighted time of 1, but because we said we're not going to assign any sort of fractional numbers, we're going to stick to the the pure kind of whole numbers. We don't have to worry about that. But then we have some employees on this task 2 here. Let's go ahead and take 2 off here and assign them to this task 3. And now we have a new bottleneck. So now the bottleneck is task 2. And that's pretty much as good as we can get this. So our recommendation is going to be reassign employees from task 2 and 5 to task 4. Reduce the bottleneck and increase capacity. You can just say something like that. But you can see here that we went from being able to get out about 2.9 units per hour to being able to get out 5 units per hour just by moving a couple people around. So it's pretty powerful stuff. Let's do a harder example. I certainly like a difficult example, a good challenge. Hopefully you all do too. So again, to get the time to completion, we just want to go ahead and add up the time for each of these times. This is just saying for one single unit, to move one unit start to finish, how long does it take? That's all this is saying. 81 minutes. That's quite a long time, isn't it? So again, I'm going to be a little bit lazy. I'm just going to go ahead and take the sum of these paths here to tell how many paths we actually have. 89. So now I'm just going to go ahead and put in 89 as a hard number. In addition to that, I'm going to go ahead and do something where I take the 89 paths, and I'm going to subtract off the sum of each of these different paths here. Because as we start to move people around, it's going to be important that we know how many employees we have to move around. So if I were to take off, say, 36 and make this 30, I know that I have 6 employees to kind of, reallocate. Okay, so let's go ahead and calculate the weighted times for all these. Again, we just take the time divided by the amount of paths going through it. Copy this down. And right off the bat here, who can tell me what the bottleneck is? Which one of these tasks is the bottleneck now?
Task 4.
That's exactly correct. So task 4 is the bottleneck because 8 is the largest weighted time. So now if we want to calculate the capacity, first we just take the sum of the weighted times. Then if we want to figure out how many we can do in an hour, for example, we take 60 divided by the capacity. That gives us 2.18 per hour. So I think we could probably do better than this. Who agrees? What should we do here? So, right off the bat here, we see we have a weighted time of 8. So let's go ahead and make this just 5 employees. So we have 22 employees to reassign now. What would happen if I went ahead and put some of these on the bottleneck? Let's say I put 18 on the bottleneck. So now I have 7 employees remaining. And that greatly is going to reduce the bottleneck. Now I do kind of want to emphasize, there are, of course, more, there's certainly going to be more algebraic ways to go about this, but we're going to keep things nice and simple. Just kind of show you a very quick and easy way to kind of reassign things. So what is our bottleneck now? Which of these tasks is going to be the bottleneck?
Task 1.
So task 1 is 7. So that is going to be the largest for the weighted time. So we happen to have 7 employees remaining. We can assign 6 of them to task 1. And now task 1 is no longer the bottleneck. But now task 3 is. So we assign our remaining employee to task 3. If we wanted to, we could certainly unassign some of these employees, and we don't need to have a weighted time of 0.2 when we have other weighted times of 2.3. So let's go ahead and reduce this. We have 24 employees to reassign now. So again, we could certainly do this all day. I don't think anyone wants to sit here and watch me do this all day, but this is how you go about this. Now, on the test, you're not going to see a problem this complicated. That's how you'd go about, solving the issue of bottleneck. You'd reduce the weighted times to where you minimize them. So that allows you to get more things through at a time. Any questions about this? So is that pretty clear to everyone? Any thing you're not clear about? Anything at all? All right, so for the final part of today's class, I have this make or buy decision. And, this looks a little intimidating, but it's really pretty straightforward. So what we want to do is we want to see, is it cheaper to purchase a product from a supplier or to make it ourselves? So to kind of calculate that, I have the cost that the supplier is charging us, and then I have the cost if we were to make it ourselves. So I have things like direct materials, direct labor, variable overhead, depreciation of equipment, allocation of general overhead, and then ultimately this is going to give us the cost per unit. So we have 10,000 unit demand. So we simply would just add up these costs here. But that's not going to give us per unit. So to get per unit, we just divide by the amount of units, which in this case is 10,000. So again, you'll be given this information. So now we're just going to compare a $5 cost per unit to a $4 cost per unit to make it ourselves. Which should we do? Should we purchase from a supplier, or should we make the product internally? So if we're comparing a $5 cost to purchase from a supplier versus a $4 marginal cost to purchase from, or to not purchase, but to basically make it ourselves, which one of these options should we do? So I got someone in chat saying to make, and that's exactly correct. I'm just going to say 4 versus 5. You guys know what that means. Yeah, so let's go ahead and do another example down here. So we have a demand of 6,000 units now. So we're going to do the same sort of thing where we take the sum of all the costs and divide it by the demand, which in this case is 6,000, gives us the same exact value. So we're comparing $5 to purchase from a supplier versus $4 to make it ourselves. So I'm just going to copy this exactly. You may say it's kind of silly. I'm going to use the exact same numbers. Well, I didn't mean to. So let's do another example here. Hopefully I use some different numbers to make it a little bit more interesting. So we're going to take the sum of all these different costs, divide it by the demand, which is 100,000 units. $1. So, as you could imagine, if we're going to compare $1 to $5, you'd rather pay $1 per unit. And then let's see this last little example here. We have 1 million units we're going to buy. I'm going to take the sum of all these costs, divide that by 1 million. And we're comparing $5 to 52 cents. So, basically the whole premise here is that as we increase the amount of products we're buying, the supplier cost probably is not going to change, but the internal kind of manufacturing costs will certainly go down. We'll have economies of scale. There's very few exceptions to that, but you'd always want to compare the two. So that's basically how you do it. You just add up the cost that you would realize. You'd get the marginal cost for the unit, which we did by just dividing the total cost by the amount of units we're going to be having. And then you'd compare the two costs. So are there any questions about anything we covered today? That's all I had today. I hope you all have a great day. I'll stick around if there's any further questions.